Welcome to this dynamic programming challenge problem. For this challenge problem, we have a set of unique coin values and a target amount. Our goal is to find the number of coin combinations that sum up to the target amount. We have an infinite number of each coin. In other words, we can use each coin value any number of times. It is important to note that we're only looking for unique coin combinations, not the total permutations. The order of the coins selected does not matter. This is LeetCode Coin Challenge 2. The link is in the description. Many of these coin problems lend themselves to dynamic programming. The way I always approach these problems is to first draw out the arrays that could provide a solution and then consider how to fill them. It's a simple step, but this has been the most helpful thing to start solving these type of problems. The approach here could be two-dimensional with an array that is the number of coins by the amount plus 1. The reason we use amount plus 1 for this problem is because we have to account for the amount 0. There is one way to make 0, which is to have 0 coins. All the other fields that are filled with zeros currently need to be updated. There are definitely 2D solutions to this problem, however I chose a one-dimensional solution. If you're just getting started with dynamic programming, be sure to take some time and try to figure out how to fill these arrays to where you could find a solution, which is going to be located in the bottom right where the green value is. With that out of the way, let's move on to my solution. To demonstrate the approach and solution, we'll use example 1. For this example, we have coins 1, 2, and 5, and we'll be targeting the total amount 5. To solve this, we'll be using 1D dynamic programming. Instead of defining a coin dimension in the DP array, we can just iterate over the coins and update our 1D array. As will be shown in the following steps, our approach is to update the number of ways one coin at a time, building up to the target amount. We begin our solution by defining the DP array. To seed the array, we note that there is always one way to arrive at the amount 0. That is to have 0 coins. That is, we have one way to have 0 coins. From here, we can step over each coin value and update the number of ways we could have arrived at that amount. We always start updating the array at the current coin value, because there will be zeros for any negative amounts. In the case of a coin with value 1, we begin by updating the ways to get to the amount 1. This is achieved by performing addition, adding the current ways to get to the amount, plus the ways to get from the previous value. We have one way to get from 0 to 1 because we only have one coin valued at 1. Then we proceed to update the number of ways to get to the amount 2. Currently, we only have one way to get to the value of 2 because we're only considering one coin. The way we arrived here is to have 2 coins each valued at 1. Once we are performing the update for the next coin, we can expect to see these numbers increase. We continue performing this step until we update the final amount we are seeking. Currently, we only have one way to get to each amount because we have only used one coin. In the case of our final amount, the one solution is to hold 5 coins, each with the value of 1. It's time to start updating for our second coin. Once again, we start updating the amount that has the value of the coin because there are 0 ways to get any negative amounts. Updating the ways to get to the amount 2, we have the previous way with 2 coins, each valued at 1. And now we have the way with a single coin valued at 2. Let's jump ahead to the update for 3. Again, we have 2 ways. The previous solution of holding 3 coins valued at 1 each, and the new solution by having 1 of each coin. Our next update is where things start getting more interesting. Notice that we have 3 ways to get to 4. This is because we had 2 ways to get to the amount 2 before increasing our value to 4. We have a similar situation to arrive at 3 combinations for a total of 5 using our first 2 coins. Now let's move on to our third coin. Our final coin adds one more solution for reaching the total amount of 5. This gives us a final value of 4 ways to reach 5. All that is left now is to return that value. The easiest way to return the final value is just to use the index of -1 to access the last value in the DP array. We can see that this matches the LeetCode sample solution. Let's submit it and see how it performs. With how efficient that simple solution is, it's no surprise to see it ranks among the top solutions. This great performance is due to its O of n times amount time complexity, where n is the length of the coins array. The real benefit of this method is the space complexity of O of amount. This was due to the one-dimensional DP array. 2D solutions would have a worse space complexity. If this video helped you, be sure to give it a like. Thanks for watching, and until next time, keep on coding on.